Assalamu alaikum sir, I am Sulyman Sifat, ID211154004, and I worked on asthma prediction quiz project with my teammate Mohammad Nazmulak Shawan ID211153996, and we would like to show you our asthma prediction project. But first I want to start by showing you the visualization. So let's get started. So this is a user-friendly quiz we created and hosted on Hugging Faces Faces to predict the likelihood of asthma based on user input. So let me walk you through the interface step by step. So this is the Hugging Face interface. So we can see the quiz title and disclaimer, and also disclaimer is very important because we don't want users to make mistakes. This quiz for a real medical diagnosis tool. So it's meant to be educational and informative. So next let's look at the questions of in our quiz. So each question is designed to capture the factors that might influence asthma risk. So these inputs reflect the features we use when training our machine learning model. So here's the list of questions users are asked to answer. So first one is gender, then age group, living area, pollution level, awareness of asthma, allergies, coughing frequencies, breathing problems, and other health issues. So these questions cover key factors that may correlate with asthma risk, including environmental, lifestyle, and health-related information. So once the user submits their answers, the quiz displays the prediction results. So let me explain how it works. So if the model predicts a low likelihood of asthma, the results might say you are unlikely to have asthma, and also it will also showing the probability of asthma. And also, if the model predicts a high likelihood of asthma, the result might say you are likely to have asthma, and the probability of asthma will also show. And also to tell the please consult a healthcare professional. So here, after users clicking the submit, the app takes their inputs and it encodes the answer into numeric values, just like we did in during our training for with using the label encoder, and it passes the encoded data to the training model, which calculates probabilities for both outcomes, no asthma and asthma. So also then it displays the result in a user-friendly format along with the color-coded asthma for red color and no asthma for green color. And if the probability of asthma is above 0.50, the result warrants the user to consult a healthcare professional. Now I'm going to explain the code and data analysis. So we have to go to the Google Club. So now we are in Google Club. So there we can see we have imported some libraries and mount the Google Drive. So we imported NumPy and Pandas for data manipulation, and Matplotlib and Seaborn for visualization. And we also mount our Google Drive to access the CSE322 dataset, which is stored in my Google Drive. And after that, we have loaded the dataset, and also we have cleaned up the column names by removing spaces and switching to lowercase. So this actually makes columns easier to understand the code for the machine. And also we visualize the data by data.head, which shows the first few rows, so we can confirm everything loaded properly. So we can see there has some small table. There was there all the features: gender, age, living area, pollution, asthma patients, and etc. And then we have visualized the data analysis. In this plot we can see there has how many yes or no entities are there in the asthma patients column. So we can see there are fewer yes for asthma than also there is lots of no. And we can see the bar chart which counts for yes or no. And after that we have encoded the categorical variables, and we have splitted data. So we actually use a label encoder to convert words like the male, female, high, low, so into numbers. So we split the features x and target y, and then we do the 80 to 20% is split for training and testing. And we our target is asthma patients here. And then we compare different classifiers, logistic regression, SVM, decision tree, and random forest. So first we have applied logistic regression model here, and we got an accuracy around 0.80, which is 80%. And then we have used SVM, which which is 0.90, which is 90%, decision tree 80%, and random forest is 0.90, means 90%. So we choose here the random forest algorithm because it's a powerful assemble model instead of using a single decision tree, and it uses many trees and takes the majority vote. This usually makes it more robust and less risk of overfitting. Plus, it naturally handles various features types and shows which features matter most. So we have lots of features here. Random forest is best for our data. So then we have improved the random forest by using hyperparameter tuning, which is used grid search CB. So we wanted the best possible accuracy and recall, especially because we don't want to miss the potential asthma cases. And then we have used smart to handle imbalanced data. Our data had more no cases than yes, without addressing this. So it is addressing this as imbalanced. The model might just predict no most of the time, so it still get high accuracy but fail to catch the actual yes cases. So these that's actually dangerous in a medical setting. So it's smart, which is synthetic minority over sampling techniques, so it creates new realistic samples for the minority class. So hence the model sees more yes examples and improves recall for asthma. So essentially it balances the classes, so our model has better chance to learn what asthma looks like actually. So after combining the synthetic data, we retrain the another random forest. Then we got 0.95, which is 95% accuracy for better prediction of yes. And also we have tried XGBoost because it's known for high accuracy and efficient handling of imbalanced data. So we have tried another model here. Finally, we have saved our model using joblib. So it is needed because we have to get this model and use it in other interface to predict the asthma patients, asthma prediction. And so we have downloaded a .pkl file, and we used in the Hugging Face interface now using Steamlit. So this is all about our project. So thank you, sir, for your patience.